So let's review all the different exponent questions for our proficiency check today. Number 1, when we multiply exponents, what do? Well, as long as they have the same base, this becomes 2 to the 3 plus 3, or 2 to the 6th. Here, we take negative 6 plus negative 7. This gives us u to the negative 13. Negative 8 to the negative 5 plus 4, or just negative 8 to the negative 1. And for our x terms here, when we add negative 5 plus a negative 4 plus 9, we end up with x to the 0. And this is a special case. Anything raised to the power of 0 is just 1. So when you're multiplying exponents, add the exponents, as long as the base is the same. Number 2, dividing. When you are dividing the same base, you subtract the exponents. For example, this first one becomes x to the 8 minus 4, or just x to the 4th. This next one is a little trickier because you have to watch out for the signs, but it becomes x to the 3 minus a negative 4. And notice we have minus a negative, so the two negatives cancel out. It ends up being 3 plus 4, so we get x to the 7th. Finally, we have x to the negative 2 minus 2, which brings it further negative to x to the negative 4th. Our third concept is power to a power. And here is when we have an exponent raised to another power. And what do? We multiply. So this becomes x to the 3rd times 6, or x to the 18th. And this becomes x to the 7 times 2, or x to the 14th. And this becomes x to the 9 times negative 9, or x to the negative 81. Number 4, simplifying perfect squares. All of these are perfect squares, which means there exists a number that when you multiply it by itself, you get what's underneath the radical. For the square root of 9, there are two possible answers. You can get 3, which you're probably more familiar with, or negative 3, because also negative 3 times negative 3 gives you 9. A better way to write this is with the plus minus symbol. This represents the same thing, a positive 3 or a negative 3, but there's less writing. For 144, that number is plus or minus 12. For 49, we have plus or minus 7. And for 121, we have plus or minus 11. Because 7 times 7 is 49, 11 times 11 is 121, and 12 times 12 is 144. Same for their negative counterparts. How about for perfect cubes? Well, we know that 2 times 2 times 2 is 8. And that's what we're looking for. What number times itself 3 times gives us 8? So our final answer is just 2. Here, turns out that 4 times 4 times 4 is 64. So our answer is 4. Similarly, 3 times 3 times 3 gives you 27. Notice, we don't include the negative answers. In fact, for any odd numbered root, we don't include the negative answers, because negative 2 times negative 2 times negative 2 would give us negative 8. Or same thing here, negative 64 or negative 27. So it doesn't work unless the exponents are even. The sixth concept is to combine roots and then simplify. So for example, if you have the square root of 7 times the square root of 7, you can change this to the square root of 7 times 7. Notice they're both underneath the bracket, which is the square root of 49, which is a perfect square. So I can simplify that. And my answer is plus or minus 7. 4 times 8 gives us 32, so this becomes the square root of 32. This is not a perfect square, so we can leave it as is. Square root of 2 times the square root of 8 becomes the square root of 16, which is a perfect square. So we have plus or minus 4. And lastly, this becomes the square root of 100, which gives us plus or minus 10. Now, on the next day, we did learn how to deal with simplifying something like the square root of 32. It's called simplifying by using perfect squares. Let me show you how it works. We have this list of numbers here, which is generated because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5, 6, 7, 8, 9, and 10 multiplied by themselves. What we do is we try to figure out the largest such perfect square that multiplies into 12 or 18 or 48 or 8. So I can try 12, and the largest number that is still less than 12 is 9. Does 9 multiply even into 12? No, it doesn't. So I try the next one. Does 4 multiply even into 12? Yes, it does. So just how in the previous section we combined something like root 4 and root 3 to get 12, we can also split them apart like this. And the reason why we might want to do this is because the square root of 4 can be simplified. It's a perfect square. In fact, that gives us plus or minus 2. And the root 3 has to carry down. So this would be your answer. The next one, 18. 16 does not multiply evenly into 18, but 9 does. So this becomes root 9 times root 2, because 9 times 2 is 18. And why 9 instead of something like 6 and 3? Because 9 is a perfect square. Again, we can only look for factors that are on this perfect square list. So this becomes plus or minus 3 root 2. 48 becomes root 16 times root 3, or plus or minus 4 root 3. Root 8 becomes root 4 times root 2, which simplifies to plus or minus 2 root 2. The last section was simplifying fraction roots by splitting them. So, for example, the square root of 100 divided by 25 becomes the square root of 100 on top and the square root of 25 on bottom. Now we're going to ignore plus or minus for these, and this just becomes 10 over 5, which can simplify to 2, because 100 and 25 are both perfect squares. Or this example becomes root of 81 divided by root of 16, which is 9 over 4. Can't simplify there. This next one, root 36 divided by root 12. The top part is a perfect square, 6. The bottom part is not. We will leave it as root 12. One day we'll show you how to rationalize the denominator, but for now, we'll leave it because it cannot be simplified as it is not a perfect square. This becomes root 1 over root 4, which is 1/2.